Hello. In this video, I'm covering section 3.1. So I'm starting chapter 3 and covering the first section. Okay, so let me share the board. And there we are. Okay, so we're starting a new chapter. Chapter 3 is on polynomials and rational functions. And the first section is going to be on quadratic functions and models. Okay, so first I'll copy the definition of a polynomial function. That's on page 304. A polynomial function f of degree n, where n is a non-negative integer, is going to be a function of this form. That's going to be the a's, an minus 1, a1 up to a0 are going to be, well, they can be complex numbers, but we're going to work with polynomials with real coefficients. Where, of course, the first coefficient is not 0. So n, the highest power, is going to give you the degree. It's going to be the degree of the polynomial. So those can be polynomials with real coefficients. And next, in this chapter, we primarily consider polynomial functions having real coefficients. When analyzing a polynomial function, the degree n and the leading coefficient are important. These are both given in the dominating term an x to the n. So I'm going to copy that. So in a polynomial, n is the degree. An is the leading coefficient. This gives you important information about the behavior of the graph of the polynomial. And an x to the n is the leading term. So some examples on the same page. A constant function. Well, we already work with constant functions. So a constant function is a polynomial of degree 0. The leading coefficient is going to be 2. Remember that any number to the 0 power is going to be 1. So you can see that as 2 times x raised to the 0 power. We also studied linear functions. A linear function is a polynomial of first degree. And the leading coefficient in this case, the leading coefficient is the slope. In this section, we're focusing on quadratic functions. So that's a polynomial of second degree. And again, the leading coefficient is the number multiplying x raised to the highest power. And 2 more examples. The fourth example in this table is a cubic polynomial that is a polynomial of third degree. The leading coefficient is 2. And a quartic polynomial is a polynomial of fourth degree. When you have x to the 4 by itself, the leading coefficient is going to be 1. So a constant function is a polynomial of 0 degree, and the function identically equal to 0 the function f of x equals 0 is the zero polynomial and has no degree. So in this section, we study polynomial functions of degree 2. Which are known as quadratic functions. Okay, so this is what a quadratic function looks like. A function f is a quadratic function if f of x is ax squared plus bx plus c, where a, b, and c are complex numbers, even though we're working mostly with polynomials with real coefficients, and a does not equal 0. A does not equal 0 because if a was 0, we would have a linear function. And we already studied those. We spent a good amount of time studying linear functions. Okay. So the simplest case, the simplest quadratic function is the squaring function. And we spent, we did this graph several times. Okay, so you remember the graph? This graph has a particular name. The graph is called a parabola. Okay, so that's a graph you already know. And the point where, at the turning point, where the graph changes from, in this case, from decreasing to increasing, is called the vertex. So the point 0, 0 is the vertex. And this parabola opens upward. Okay, so let's do a transformation. Let's reflect this graph across the x-axis. Consider now let's call this g of x the opposite of x squared. And you learn in section 2.6 that the graph of the opposite of x squared is going to be the graph of y equals x squared reflected across the x-axis. Okay, so I'm not going to make a table, just a graph. The graph is going to be reflected. Okay, so this passes through -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. Okay, so again, the vertex is 0, 0, and the parabola opens downward. So we have two situations. We have two general situations. The vertex will not necessarily be 0, 0. We're going to work with the transformation like shifts, stretches, shrinks, and reflections. But in general, you have two cases. Whatever the vertex is, you may have a parabola that opens upward or a parabola that opens downward. The turning point is called the vertex. And the line that passes through the vertical line passing through the vertex is called the axis. So in the examples we did, so in the examples we did, f of x equals x squared and u of x equals the opposite of x squared. The vertex is at the origin. And the axis is the y-axis or x equals 0. Okay, in general, a more general case, let's suppose that f of x is ax squared. Okay, so you know that a will cause the graph to vertically stretch or shrink. It's going to stretch if a is greater than 1, and it's going to shrink if a is between 0 and 1. And if a is negative, the graph is also going to reflect across the x-axis. So if a is positive, the graph is going to vertically stretch or shrink, but it's not going to reflect. So the parabola opens upward. And if a is negative, the graph is going to reflect across the x-axis, and the parabola opens downward. On both cases, the vertex is at the origin, and the axis is the y-axis or the vertical line x equals 0. Let's do another example. Now we're going to let f of x be x plus 2 squared plus 1. We studied the transformations of functions, and we learned that the graph of y equals x squared is going to be shifted 2 units to the left and 1 unit down. So is shifted or translated two units to the left and 1 unit upward. Okay, so the graph, that's going to be the same graph as x squared, but it's going to be shifted. Okay, so that's going to shift 2 units to the left. So the vertex will have x coordinate -2 and at -1. There is no reflection. Okay, so you're shifting the vertex from the origin to -2, -1. And then the other points are going to be -1, 0, 0, 3, -3, 0, and -4, 3. Okay, so the vertex of the parabola is at -2, -1, and the axis is the line passing through the vertex. So the axis is x equals -2. So the axis will be given by the x coordinate of the vertex. Let's do another example. Let f of x be x minus 3 squared plus 4. Okay, so the graph of y equals x squared is going to be shifted 3 units to the right and 3 units upward. So the graph of, I'm going to leave some space, is shifted. So that's going to be the graph of y equals x squared. Shifted or translated. And that's going to be translated three units to the right and 4 units upward. So let's sketch the graph. The vertex is going to shift from 0, 0 to 3, 4. Okay, so that's going to be the vertex. 3, 4. And then 1 to the left, 1 up, 1 to the right, 1 up. And then 2 to the right, 4 up, 2 to the left, 4 up. the vertex, not the vertex, the axis is the line, the vertical line that passes through the vertex. Okay, the vertex is then 3, 4, and the axis is x equals 3. So the last two examples were nice because the parabola was given in vertex form. But it's not always going to be the case. Well, you can write in one or another way by completing the square or by foiling. But in general, any quadratic function f of x equals ax squared plus bx plus c can be written in vertex form. In vertex form, so that's going to be the leading coefficient is going to be the same. And we can write it in terms of the vertex x minus h squared plus k. So the vertex of that parabola is going to be hk. Always. The vertex is hk. The axis is the axis or axis of symmetry is x equals h. And if a is positive, the parabola opens upward. And if a is negative, the parabola opens downward. So to write in vertex form, from vertex form to general form, there's not much of a problem. You can just FOIL. But to convert from quadratic to vertex form to general form to standard form, from standard form to vertex form, you can either complete the square or I'm going to give you the vertex formula. But with the started two cases. Okay, first case is a parabola with vertex at hk that opens upward. So that's the vertex. That's the case when the leading coefficient is positive. And the other one is the case when the leading coefficient is negative. The axis of symmetry is going to be the line passing through the origin. Okay, so you can always rewrite. You can rewrite the quadratic function ax squared plus bx plus c in vertex form. with the same leading coefficient, but you have it in terms of the vertex. And you can do that by using the vertex formula. So this formula is not in the book. I'm just giving that to you. Okay, the vertex formula. The x coordinate of the vertex, that's going to be h. And that is the opposite of b over 2a. And k is going to be f of h, or f of the opposite of b over 2a. So I'm going to do a few examples with quadratic functions. We are going to find the vertex in the next examples. We are going to find the vertex, the axis, intercepts, and open intervals where the function is increasing and decreasing. First example is f of x equals x squared minus 6x plus 5. So we can start, we want to find the vertex and the axis. We can start by writing the function in vertex form, where all I need is a and b. C is not going to be important in the formula, in the vertex formula. Okay, so a is equal to 1, and b is equal to -6. So let's find the vertex. The vertex is the opposite of b over 2a, comma, f of the opposite of b over 2a. So the opposite of b over 2a, this one. This is the opposite of -6 over 2 times 1. So that's 6 over 2 or 3. So that's the value of h. And k is f of 3. This is 3 squared minus 6 times 3 plus 5. That is 9 minus 18 plus 5. This is -4. Okay, so I do have the vertex. The vertex is 3, -4. And the axis is x equals 3. Okay, we can next find the intercepts. So we have the vertex and we have the axis. Okay, let's find the y-intercept. That's the easiest one. All we need to do is evaluate the function at 0. The function is, let's look at the function again. That's 0 squared minus 6 times 0 plus 5. So the y-intercept is 0, 5. Let's find the x-intercepts. We can find those by solving f of x equals 0. That is, we can either write the function in standard form or in vertex form. But to me, it's going to be easier if I do it in standard form. That's x squared minus 6x plus 5 equals 0. It's not always going to be that nice. But in this case, we can do that by factoring. This factors as x minus 1 and x minus 5. So the x-intercepts are, the solutions are 1 and 5, and the x-intercepts are 1, 0, and 5, 0. And I didn't write this down, but we know that we know that f of x the original function is x squared minus 6x plus 5 in standard form, and in vertex form is the same as x minus 3 squared minus 4. So we are going to draw the graph. We have a good amount of information. We know the vertex, we know the intercepts, so that's going to be enough information to sketch the graph. And I have one more question. I'm going to determine that from the graph. Well, I don't need the graph to determine that, but I'm going to draw the graph. See, I'm trying to I'm trying to draw straight. Okay, so the vertex was 3, negative 4. Okay, so that's the vertex is 3, negative 4. We also found the y-intercept. The y-intercept is 0, 5. And the intercepts are 1, 0, and 5, 0. So that's going to be the graph. And finally, the axis is also x equals 5. So I can also draw that. Or x equals 3. Not x equals 5, x equals 3. Okay, so finally, this function is increasing. We're just going to write only the open intervals. This is increasing. Over 3 to infinity. And decreasing over negative infinity to 3. Okay, next example, we have the same questions. We have the same questions for the following function, f of x. Let's call this number 2. Same question for f of x equals the opposite of 2x squared plus 4x minus 4. So for that, we have the same questions. So it looks like I will not be able to factor that whenever I want to find the intercepts. That's not a problem. I can use the square root property. I know that a is -2 and b is 4. So let's find the vertex. H is the opposite of b over 2a. So this is the opposite of 4 over 2 times -2. So that's the opposite of 4 over -4, or 1. And k is f of 1. So that's going to be -2 plus 4 minus 4, or -2. So now I know the vertex. I know that the vertex is 1, -2. And that function, I can write it in vertex form. So that's the vertex. This function is the same as -2 times x minus 1 squared minus 2. And if I know the vertex, I can quickly determine the axis. The axis is x equals 1. Okay, so what do we do next? We are going to find the intercepts. So the y-intercept is the easiest one. Let's start with the easier one. The y-intercept is given by f of 0, so that's 0 plus 0 minus 4. So I know that the y-intercept is 0, -4. Okay, we're going to find the x-intercepts, but we're going to use the vertex form, because that one, I don't know how to factor this. Okay, so we have that. For the x-intercepts, we are going to solve f of x equals 0. So let's use the vertex form. This is the opposite of 2 times x minus 1 squared minus 2 equals 0. Or the opposite of 2 times x minus 1 squared equals 2. Divide by -2, and x minus 1 squared is -1. But that's a problem, because when I try to solve this, I have that x minus 1 is plus minus the square root of -1, which we learned that this has no real solution. This has complex solutions. So this graph has no x-intercepts. From the vertex, we can determine the intervals. From the leading coefficient and the vertex, we can determine the intervals where the graph is increasing or decreasing. The leading coefficient is negative, so the parabola will open downward. But let's draw the graph with the information that we have. We found that the vertex was 1, -2. Okay, so the vertex was 1, -2, and the y-intercept was 0, -4. Okay. Okay, so the vertex is 1, -2. The axis or axis of symmetry is x equals 1. The y-intercept we find this to be 0, -4. So we have that part. And if the graph passes through 0, -4, it's called the axis of symmetry for a reason. That is 1 to the left, 2 down. So 1 to the right and 2 down. This will also pass through the point, 2, -4. It's going to be symmetric with respect to the axis of symmetry. And finally, this function is increasing over -infinity to 1 and decreasing over 1 to infinity. Okay, one more example. I'll do one more example and an application to finish this section. So number 3. Same questions for the function f of x equal the opposite of x squared minus 4x minus 1. We're going to find the vertex, axis of symmetry, intercepts, and the interval where the function is increasing or decreasing. Okay, so a is -1 and b is -4. Let's start with the vertex. H is the opposite of b over 2a, or the opposite of -4 over 2 times 1. Okay, so that's going to be 4 over 2 or 2. And k is f of 2. This is the opposite of 2 squared minus 4 times 2 minus 1. So this is what? This is -4 minus 8 minus 1. Or let's see, am I? Okay, making sure that everything is correct. Oh, yes, I see what I'm missing. So that's a -1. Yeah, this is -1. And then we have a minus. We have 3 minuses. So that's going to be minus. And that's going to be -2. So let's plug it in. That one doesn't change. That's the opposite of -2 squared. Minus 4 times -2. Okay, so that's -4 plus 8 minus 1, which is going to be +3. Okay, so I know the vertex. The vertex is -2, 3. And the axis is x equals -2. And I can also write this function that I began with. This is the same as the opposite of x plus 2 squared minus 3, plus 3. So these two functions are the same. So what do we do next? We're going to find the y-intercept. Okay, the y-intercept is given by f of 0. So that's going to be 0, -1. The x-intercepts, we're going to use the, I will not be able to factor the quadratic function in standard form, so I'm going to use the vertex form. The last one didn't have any x-intercepts. For the x-intercept, we're going to solve f of x equals 0. So this is the opposite of x plus 2 squared plus 3 equals 0. So that's the opposite of x plus 2 squared equals -3, and x plus 2 squared is equal to 3. So x plus 2 is plus minus square root of 3. So x is -2 plus minus square root of 3. The x-intercepts are then going to be -2 minus square root of 3 comma 0, and -2 plus square root of 3 comma 0. Now that one will not be easy to graph, but for a quadratic function, I only need 3 points. So that's what I'm going to use. We found that the vertex of the graph, the vertex of the parabola, is -2, 3. Okay, so that's the vertex of the parabola, -2, 3. And the y-intercept is 0, -1. So the axis of symmetry passes through the origin, not through the origin, through the vertex. We also know another point, 0, -1. That means we go 2 to the right, 3 down. So we can go 2 to the left and 3 down. So we can get a second point from there, or a third point. That's -4, 1. And that's going to be the graph. The x-intercepts are going to be somewhere between -4 and -3, and between -1 and 0. So finally, this function is increasing. Over -infinity, -2, and decreasing over 2 to infinity. Okay, so the last thing the last example is an application. That's number 68. Okay, so that's on page 317. If an object is projected upward from an initial height of 100 feet with an initial velocity of 64 feet per second. Then its height in feet after t seconds is given by this quadratic function. Find the number of seconds it will take the object to reach its maximum height. And what is the maximum height? So it's always good to draw a picture of the graph. So that's a function depending on t. We can see that the y-intercept is 0, 100. That the parabola has a negative leading, that the function has a negative leading coefficient. So the parabola opens downward. So the graph is going to be something like this. Okay, so the maximum height is going to be given by the vertex. So that's going to be the maximum height. So let's find the vertex. In this function, a is negative 16 and b is 64. H is the opposite of b over 2a. So that's the opposite of 64 over 2 times negative 16. This is negative 64 over negative 32 or 2. And k is f of 2. So that's the opposite of 16 times 2 squared plus 64 times 2 plus 100. Negative 2 squared is 4. 16 times 4 is 64. 64 times 2 is 128. So negative 64 plus 128 is 64. 64 plus 100 is 164. Okay, so we found the vertex. We know that the vertex is 2, 164, and that will answer the questions. It takes 2 seconds to reach the maximum height. So it takes 2 seconds for the object to reach its maximum height. And the maximum height is 164 feet. Okay, so this is it, discover section 3.1. Thank you for listening.